Okay, so let's talk about horizontal asymptote. So as always, let's define what an asymptote is. So an asymptote is an imaginary line that our graph approaches but never actually touches. So since we now know how to find the vertical asymptote without plotting any function, now we're going to learn how to find the horizontal asymptote without drawing any graph. So horizontal asymptote is a imaginary, or we could say an invisible horizontal line that our graph would approach but never actually touch. So there are three types of cases that we need to consider while trying to find the horizontal asymptote. We're not going to be plotting any functions, so we're going to look at these three cases and then we're going to see what is our horizontal asymptote, or if our horizontal asymptote exists or not. So in the first case is when the degree of numerator is smaller than the degree of the denominator. So at the degree of the numerator is 1, so I have 1 over here, and the degree of the denominator is 2. So in this case, the degree of the numerator is smaller than the degree of the denominator. So whenever we have this case, our vertical asymptote would be y equals to 0. It's basically the x-axis. So this graph over here would approach x-axis but never actually touch x-axis. So that would be y equals to 0. It's the horizontal asymptote of this function over here. So now let's look at the second case. In the second case, we're given the degree of the numerator is equal to the degree of the denominator. So here the degree of the numerator is 2 and the degree of the denominator is also equal to 2. So in this case, the vertical asymptote is basically the ratio of the coefficients of the axes that have the maximum power. In this case, the axes that have the maximum powers are these two because the degree is 2. So we could do this. So we could simply divide 8x squared by 3x squared, as these are the axes with the maximum power over here. So x squared and x squared cancels out and we're left with 8 over 3. So this is our horizontal asymptote over here, y equals to 8 over 3. Basically the ratio of the maximum, or we could say the ratio of the axes that have the maximum power. You could simply divide these terms to each other and you would get the horizontal asymptote. So this is the case when our degree of the numerator is equal to degree of the denominator. You simply divide these two terms and you would get the horizontal asymptote. So now we're going to look at the third case. So in the third case, our degree of the numerator is greater than the degree of the denominator. The degree of the numerator over here is 2 and the degree of the denominator is 1. So when you have such case, you should know that the horizontal asymptote doesn't exist. So once again, I'm going to recap. So we have three cases while trying to find the horizontal asymptote without plotting any function. So firstly, we have a case where our degree of the numerator is smaller than the degree of the denominator. So in this case, the horizontal asymptote is y equals to 0, basically the x-axis. And in the second case, we have the degree of the denominator is equal to the degree of denominator. So in this case, when our degrees are equal, then we simply divide the two terms and then the ratio of the axes that have the maximum value would be our horizontal asymptote. And thirdly, we have a case where our horizontal asymptote would not exist, and that is when the degree of the numerator would be greater than the degree of the denominator. So make sure you make the habit of looking at the powers and the degrees and you compare those degrees with each other, and this is how you're going to find the horizontal asymptote.